There we go. Okay, so as you're sitting back down, so I'm going to talk to you about the human landing system a little bit. There is a blackout for the synopsis, so we can't go into a lot of details, but I'm here representing the Human Landing System program. Lisa Watson-Morgan is here. She's the program manager for that. So we intended to be here yesterday. Actually, we're actually in town, but we had to be at headquarters, and so we were wanting to hear what's going on with science and so forth, but we didn't get to hear yesterday, but we're here today. For HLS, as you know, there's an Appendix H solicitation out. We're expecting a lot of very innovative solutions to come back, but we can't talk about that right now. And let's see here. There we go. So, but there's a few things we want to talk about, support across the mission directorates, and then I wanted to talk about one of the requirements, specifically the upmass requirement that we put in the solicitation. As you see here, and you've seen this chart, and I want to reference back to what Marshall Smith and John Connolly showed in their charts previously. Instead of repeating a lot of the charts, I'm just going to reference what they had. But you'll see over on the left is a reference architecture with a descent element and an ascent element. And NASA came up with a reference architecture just to show feasibility with the constraint of launching on commercial launch vehicles, which required multiple elements to aggregate in NRHO. So that was our reference, just to show feasibility of what we had. So as we move forward, though, we're going to continue to coordinate across the mission directorates, and that's what I wanted to message. Artemis is not just a HEO mission. It's a NASA mission with commercial and industry partnerships. And as the administrator clearly articulated last week at IEC, we're going back to the moon, we're going back to stay, and we're going to have commercial partnerships and international partnerships. So that was a clear message from last week. In our coordination across the mission directorates, we have STMD, and you heard a lot from Nikki a few minutes ago. There have already been tipping point awards made that are supporting the human landing system through technology development that have the potential to on-ramp and enhance and increase the capability of the initial human landing system. I have other up there because, as Nikki alluded to, there may be other mechanisms and other technology investments that we haven't even brought out yet. And then with SMD, we have the Commercial Lunar Payload Services, CLPS, that you've heard a little bit about and we'll hear more about. That's relevant to the human landing system for testing some of the technologies that will on-ramp to the human landing system. And then the last bullet here is that we're looking to SMD to prioritize the science objectives of Artemis 3 and coordinate with HEO on science objectives for Artemis 4 and beyond. So the science that's performed as part of the Artemis missions is led by SMD. Jake Bleacher is our resident HEO scientist and coordinates with Ben Bussey and Steve and Jay on these activities, and we're going to keep ramping up on that coordination. I've got Steve's cell phone, so based on the pace that we're going, and you saw Marshall Smith present that chart, our meetings may be between midnight and 6 a.m. just to fit them in during the day, so going forward. Let's see. So what came out in the solicitation was the program had requirements and objectives. This one in particular talks about HLS will accommodate at least 100 kilograms of science experiments and technology demonstrations, including 35 kilograms of return mass to lunar orbit. Previously, we had 100 kilograms down mass and 100 kilograms up mass. But you guys all understand physics. Getting there quickly with technology we currently have in 2024 was very challenging. We had no margin on the return mass. And so we poked on several areas, including the suits. We tried to minimize that mass as much as we could, and we ended up needing to reduce the threshold. Explain what I mean by that. All right, so this is the requirement. If you haven't had a chance to go read the solicitation that's out on FedBizOps, I have a link to it at the end of this presentation so you can go see. But we'll be capable, the requirement is to be capable of returning scientific payload of at least 35 kilograms. That's the minimum. So for missions where there's requirements, and you may think a requirement of 35 kilograms, that means 35, not 36. That's not this requirement. This requirement is the minimum is 35 with the goal of 100 kilograms. And we've clearly communicated to the companies that they will be evaluated on their ability to get, or evaluated more favorably on their ability to get closer to the 100 kilograms. So we're trying to incentivize that. One of the reasons for having the threshold is we're planning to carry at least 2 companies to flight. So if we had one company that could make it, we may think, okay, we'll just go with that company. So, but we're going to have 2. So we're trying to make it so that we can have 2 providers that can go towards 2024, and the next one will fly in 2025. As Marshall Smith mentioned earlier, we have sustaining requirements in the solicitation that increases the capability. So we're messaging that we're going to go back to the moon many times with increased performance and capability. So, so as you see here, we actually broke out the mass for the 100 kilograms for the goal in this table, which provides 20 kilograms for the sample return and 80 kilograms for the samples. The minimum threshold being 35 kilograms with 9 kilograms of sample return. 9 kilograms of equipment of the box and 26 of lunar samples. Now, it's not just the ability for HLS to bring the mass up. This has to come back through Orion and back down. So we're coordinating with Orion on the volume capability to bring it back as well as the mass. So, and that's what I think John alluded to earlier as well. And that's the footnote at the bottom. So there's more than just the HLS capability to bring the mass back up. So what would be, we should start thinking about are other ways to bring sample back besides just through Orion. If the crew could collect samples and place it in a return vehicle that's a robotic return vehicle that CLIPS delivers or something like that, then there's other ways to get samples back other than just through HLS. Okay, we'll come back to this one. Maybe we'll take some, I heard questions earlier about sample return and mass and so forth, so we can answer any of that. The message is, this is the starting point. It's not the end. Okay, so as I mentioned earlier, these are the links to go look at the solicitation and the next step 2 documentation. To look at, there's the EVA duration, there's the number of EVAs that we would have, and the surface stay time that all connect to how much sample that can be collected. So let me pause there just a minute, because I want to leave enough time at the end to maybe even have a discussion, answer some questions about the upmass sample return. So I'm going to stop here and wait for questions if that's okay. And the moon is not a stepping stone, by the way.
So I agree that capabilities will evolve as risk is retired and we get more risk tolerant or risk tolerance or risk retirement. But that note you had at the bottom of your previous slide that Orion does not have dedicated capability to return samples means that we're starting to get in. Now got a 3-stage human lunar lander coming back to a gateway, and now we need a robotic sample return vehicle. It's getting very complicated. And I assume that Orion cannot be modified to take samples unless we leave an astronaut behind. It would probably not go down very well. But there again.
So Marshall Smith just left, or I would defer that question to him regarding Orion.
Right. Okay, so you're going to defer to him. You're punting.
On the Orion capability.
Okay, but the idea of having, a robotic sample return, yesterday we talked in the science, I wish you would have been here, about a sample return campaign. So there may be something to think about in terms of what the community here, the science community, is thinking about samples, and what you're thinking about with robotic sample return. Maybe there's some discussion that could be had here in terms of linking the science with the exploration, as they're going to do the same thing. So, but I think there's an opportunity here, but it does bother me that we're getting, well, we're going to need another vehicle now. We're going to have to do this. So, all because Orion is. Well, Orion. Yeah, well, I'll add to that. So our team will be at JSC next week, meeting with the Orion program office and talking about the interfaces and so forth. And it'll be part of the conversation. We don't know that we can carry this big of a box with samples. It may be this big. So Orion not being just mass challenged, but volume challenged. Yeah, right. So it's not, we haven't conceded that it's zero back on Orion yet. We just don't know what the capability will be.
Yeah, and so Jake Bleacher at NASA headquarters. So yeah, to be clear, exactly what Greg just said, it's not that Orion can't bring samples back, it's that they don't, it's not take the sample box out of the Ascent module and there's a spot for that box in Orion. Right. So we have the negotiating that we're doing with them is exactly what Greg said, trying to define how that moves. So we have to think very creatively about how we store our samples. So this gets into our curation side for the human landing system. And if there are special needs, those have to be accommodated as we bring them back as well. So it's basically a mission by mission assignment on how we will store and return the samples.
Thank you, Jake.
Catherine Robinson, Lunar and Planetary Institute. On the point of special needs for curation, are there any plans to develop a cryogenic system for bringing samples back?
So there has been discussion about that. We don't plan to do that for 2024. That was brought up. Remember, it's very aggressive to get to 2024. Beyond 2024, in the next phases, there is intentions to develop that cryogenic storage capability. We don't have that yet, nor the details, but we realize if we're going to take samples out of a PSR, we don't want them to evaporate before they come back. So there is intentions, but not for 24.
Thank you.
Dean Epler, Aerospace Corporation, back about a decade ago, a number of us working with the CAPTEM team really looked at return capability and not just samples. And one of the things that came up with the discussions with the engineering director at Johnson is that geologic samples are not the only thing you're probably going to want to bring back. Things that break, things that don't work as advertised, material samples, human samples, and I'll leave it up to everybody's imagination what that is. All are going to have to come back. And that's an issue. I mean, return samples aren't just rocks for nutty geologists. There are a lot of stuff that have to come back. And a lot of stuff comes back from space station. I spent 11 years in the payloads office working that issue too. So this is a real issue, and Orion's got to have to step up to it, or they're going to be scrambling. And that's just the way it is, so.
Okay, thank you.
Pamela Clark, JPL. I'm hoping that you're going to be very flexible in how you do the payload, because there are some of us who like to have a lot of small things, even much less than 35 kilograms, that we put on the lunar surface. So when they carry these things they have the requirement to carry 35 kilograms or more. We need an architecture that could potentially allow people to combine payloads and maybe deploy them somewhat differently, if that's possible. That would be very helpful.
Yeah. So again, Jake Bleacher is our HEO scientist, coordinating with Ben Bussey, Steve Clark, Jay Jenkins, and we look for them to help establish how you can combine payloads or arrange payloads or stack the payloads, how they're broken up into separate boxes. Is it a long, skinny shovel? Things like that. So I turn around and point that question back to Steve to keep us informed about what the science needs are.
Yeah, Mark Robinson, Arizona State University. This may be a question for beyond the first landing, but are there folks working on ways to make certain that astronauts can sample smarter than we did during Apollo, and down select once they've collected things and they've gotten back to the equivalent of the LM, whatever we're calling it now? For instance, when I used to be a rail geologist, we would do that at the end of the workday, and you'd end up with a big pile of rocks where you were camping that you left behind because some of it was redundant, and you just narrowed it down because we were carrying everything out in a helicopter. So that seems to me be a critical part of making that 20 to 100 or 20 to 80 kilograms much more valuable in terms of what we brought back from Apollo, is smart sampling and down select.
Okay. Yes, and I think Ben is racing Jake up to the microphone to address that.
Yeah, to answer that question, that there are people thinking about tools, and also with regards to high grading samples. We're going to have a workshop next year, and one of the topics of that is what are the instruments we want the crews to have so they can do exactly that. They can analyze the rocks, because it could be, particularly when it's particularly limited, what they can bring back.
Yeah, and that workshop's going to be really important for gathering community input on this. But I also want to emphasize that this is, just talking about going from HLS to Gateway to Orion, tools and instruments and curation capabilities are all also going to need to be integrated. So it's just, we have to understand from the science community, from SMD, what are the specific goals you want to address? What kinds of samples do we need to get back? What additional data do we need so that we can build those systems to enable us to literally identify it on the ground, pick it up, potentially high grade it? And you're right, in 2024, we're not going to be in that complicated of options, but we will be working our way towards that, as Marshall was talking about. So again, we're going to be trying to get more community input on this, and we really encourage everyone to take those opportunities to tell us what we need to hear.
Okay, I think I'm out of time, but yeah, I want to thank Jake and Ben. We're looking to them to help with the coordination across HEO and SMD, and to work with us on the mass, the volume, how to break up the payloads and bring the samples back and so forth. So thank you.